So the key idea behind simplifying rational expressions is that you want to factor the numerator and the denominator completely, and then once you've got it factored, you can reduce factors that are the same. Okay, there's the restriction piece that we need to talk about as well. So my example 2 says evaluate 7 divided by 0. And you can in fact pick any number that you like and try to divide by 0, and on your calculator you get an error. We cannot divide by 0. So we cannot divide by 0. Okay, so that means we place restrictions on our variables. So for example, if I had 7 divided by x, that's going to work as long as x is not equal to 0. So our restriction is x cannot equal, so an equal sign with a line through it, cannot equal 0. So our restriction is any value of x that would make the denominator equal to 0 has to become a restriction. So if, for example, I had a different expression, let's say I had 7 divided by x plus 5, I know that my x plus 5 can't equal 0. Okay, which then if I try solving that, get x by itself, I would subtract 5 from both sides. Subtract 5, and I get a restriction that x cannot equal -5, because if it was -5, I would have -5 plus 5, and then the denominator would equal 0. So once you have your expression in its factored form, just make sure you set each factor not equal to 0 and solve for the value of x so you can get what the restriction is going to be. So our next example is to go back to example number 1 and put restrictions on the variables for each part. So if I look at my examples that we have here, I don't have any variable on the denominator of this fraction, so there's no restrictions here. It's only when you have variables on the denominators. Here, our denominator is just the x, so our restriction will be that x cannot equal 0. Similarly here, I have a 3. 3 is a 3. It will never equal 0 by itself. But 3 times x will equal 0 if x is equal to 0. So x cannot equal 0 here. Part D, 3 is just a 3. It will never equal 0, so there's no restriction on that one. Here, x times x squared cannot equal 0, which means x cannot equal 0. No variable on the bottom here, no restrictions. X plus 5 cannot equal 0, which means then that x cannot equal -5. Okay, and again, we're looking at the factored form. So in part H, I've written the factored form down. 6 is always just a 6. I don't have to worry about that, but my 2x plus 1 cannot equal 0. So if I treat that just like a regular equation, subtract 1 from both sides to get x by itself, I get 2x cannot equal -1, and then divide both sides by 2, my x is not going to be able to be equal to -1/2. So that's my restriction for part H. For part I, I've got a couple of things that make restrictions here. 8 is just an 8. I don't have to worry about that. My x cubed cannot equal 0 because it's a factor. So I'm looking at each factor here. X cannot equal 0. And then from this piece, I have x plus 5 can't equal 0, which up above we have already solved for. X cannot equal -5. And then the last two here, my restriction is my denominator cannot equal 0, which means each one of these factors cannot equal a 0, because if x minus 5 was 0, I'd have 0 times another number, which would still be 0, and my x plus 2 cannot equal 0, because if it was 0, I would have x minus 5 times 0, which is 0. So I have two restrictions coming out of here. I would have x minus 5 cannot equal 0, which means x cannot equal 5 when I solve that for x. And I also have x plus 2 cannot equal 0, which solving for x cannot equal -2. So part J actually has two restrictions on x, two values there.